Right, the last part of this worksheet has to do with word problems and using slope in context. So it says that slope can be used to solve word problems involving rate of change, which you might have heard before in algebra, which is essentially just slope in context. The slope compares the change in two different units. So miles per gallon, feet per hour, anything like that where you're comparing two units, we're using slope, but it's just with some kind of context or story to it. So for the first one, it says state law requires that accessibility ramps have a slope of 1 to 12. In other words, for every 1 foot of vertical change, there must be 12 feet of horizontal change. If a ramp has a height of 3.5 feet, how much horizontal distance must the ramp cover? So I know that according to law, the rise over run has to be at least 1 over 12. And then on our ramp, we know that it has a height of 3.5 feet. So think, is that rise or run? But as a height, that's going to be rise. And they want to know how long would that ramp have to be to go along with these standards. So if I have a height of 3.5 feet, how long, what must be the horizontal distance of that ramp? So if you're thinking about how we can solve this, we need this ratio to equal this one. So if I set those equal, you need to think about how we would solve that. Hopefully you remember cross multiplying in the past. So what we're actually going to do is we can call this a variable, we'll just call that x, and we can cross multiply. If I do that, 1 times x gives me x. 3.5 times 12 gives me 42. So my answer would be 42 feet. Now, if you want to check, if you're not quite sure, just take 3.5 times 12 and see if you get that 42 feet in the bottom, if that is correct. Again, if this is 1 over 12, this ratio needs to be equal to this one. So if I can multiply by 12 to get down here, I should be able to multiply by 12 to get down here as well. So that's one example of using slope in a problem. The other example, which you're going to get to practice as well, is when you're given a word problem and you actually have to pick out 2 ordered pairs from that word problem. So this problem says, in 2012, Mr. Thomason's car was worth $17,550. By 2015, the car's value decreased to $16,100. Find the rate of change in value. So it sounds like we want to figure out how much is this car decreasing over how much time. We have years and we have dollar amounts. So we're going to compare those. So the first point I got from the first part of the sentence was 2012, $17,550. How many years, or the year of the car, and then the amount. My next point is 2015, and the new value of the car, $16,100. So now all I have to do is find my slope. I'm going to subtract my y's, so 16,100 minus 17,550 over 2015 minus 2012. You can go ahead and simplify that while I grab a calculator. So if I take 16,100 minus 17,550, I get negative 1,450 on the top, and I should get a difference of 3 on the bottom. Now, this is a little bit helpful because it's telling me I'm going down negative $1,450 every 3 years. But we can simplify this further. I want to know every year how much is this car changing. So to do that, I can just divide to simplify. If I divide negative 1,450 by 3, I get a decimal, which is fine, and I'm just going to round it. So I'm getting that it goes down in value negative $483.33 per year. Now, if you flip over to your worksheet, your last few practice problems are numbers 10 to 12. Once you finish 10 to 12, you can check your answers on the key, and you can also continue following that checklist. Make sure you try the challenge problems when they come up on the checklist, okay? Just because they're challenge problems doesn't mean they're impossible. You guys can definitely do those.